All right, folks, today we are talking about compound Boolean expressions. So if we remember from our last discussion on this unit, we talked about ifs and elifs, and I guess also elses. So we have our if condition. When that's true, we'll run our if body and then continue running our program. When our if is false, we'll check our else if. If that was true, we'll run that body. If it was false, we'll run the else. You remember all of this from last class. Today, we are going to be combining Booleans together. So sometimes it's useful to combine multiple conditions to form a single if statement. And we can do this using these things called logical operators. And there are three of them. There's not, there's and there's or. All right. Those are our three logical operators. These work with Boolean values, and they will also give us Boolean values. So let's look at how they work. The exclamation point is our not operator, and it will just flip a Boolean value to its opposite value. This is a unary operator. It only needs one value to operate on. So I can say if I have a variable x, a Boolean value x, when x is true, not x is going to be false. When x is false, not x is going to be true. It's just going to flip-flop it. So if I have a little example, if I have a variable called light is on, I set it to equal true. I print light is on, I'll see light on true. If I say light is on equals not light is on, not true is going to equal false. So now light on will be false. So this is useful for flip-flopping our Booleans back and forth if we so choose. The double ampersands, this is our and operator. And or are both binary operators, meaning they need two values in order to do their thing. And will give us true when the Boolean on both sides are true. So if I have Booleans x and y, when x and y are both true, x and y will equal true. When one of them is false, or when both of them are false, x and y will also be false. So, and will only give us true when both things are true. Let's look at this example. So if it is sunny, and that's true, and warm is false, nice day is going to equal true when is sunny and is warm are both true. Sunny and warm, true and false, that's going to give us false, so it is not a nice day. Somehow it's sunny and not warm outside. So we can use an and to combine those Booleans together. If it is actually warm, true and true will give us true this time. So now it will actually be a nice day. The or operator, and that's using two vertical lines. So that's shift and the key above your enter. It's where we have our backslash. The backslash key, the shift version, is the vertical line. So double, I think they're called pipes. So double pipes are is the or operator, and also a binary. We need two values, and or will give us true when at least one of the Boolean values it's working with is true. So if x and y are both true, at least one of those is true. X or y will be true. In these two rows, at least one of x or y is true. Therefore, our x or y going to give us true. And our last row, both are false. Not one of them is true. So we're going to get a false from our or. So if for an example of this, we have our is on Wi-Fi equaling false, is on mobile data equals true, and connected to internet is going to equal is on Wi-Fi or is on mobile data. If you're connected to one of those two things, you're connected to the internet. So is this going to be true? Are we connected to the internet? We are connected to the internet because our phone is on mobile data in this example here. So there are two scenarios where we can take a shortcut using these two operators. Anytime we use the AND operator with a false, we'll always get false. And anytime we use OR with true, we're always going to get true. So because of this interaction, we can sometimes skip actually needing to check that second condition. False and any Boolean value, true or false, always going to give us false. True or any Boolean value, always going to give us true. So since the values within those anythings don't matter for the outcome, Java is going to just automatically skip evaluating those expressions. It's just going to not check them. And this is called short circuit evaluation. When Java sees, hey, false and, I don't even need to check this other thing, we're just going to skip it. So let's look at an example of how we might use this. Let's say we want to check that we have enough pizza to spread among everyone. Let's say we have 10 slices of pizza and we have 0 people. We're going to check if our number of slices divided by our number of people is greater than 0. If we have at least 1 slice per person, we can say there's enough pizza. Otherwise, there is not enough pizza. But there's a problem here. Since num people is 0, we're going to be dividing by 0 here. Divided by 0 is not going to work. We cannot do that. That will crash our program. Just like you can't do it in math, computers also can't divide by 0. It can't be done. So to fix this, we can add a condition to our if statement. We can check if our number of people does not equal 0 and our number of slices over number of people is greater than 0. So if my num people does not equal 0 is false, because I have an and here, it's not even going to try doing this division. It's just going to skip that second half of this evaluation because we had a false and, so it doesn't matter what this second thing is. We're just going to skip it. So when that condition is false, we have no reason to check the other condition. If I change my num people to equal 5, now num people does not equal 0. That's going to equal true. So we can actually check whether num slices divided by num people is greater than 0. So is num slices over num people greater than 0 here? Yeah. In this scenario, everyone gets 2 slices of pizza. So that's how we can use short circuiting to prevent crashes in our program. Just like in math operators, we have an order of operations with these logical operators. The not is the first thing to happen, and it is evaluated before the and is evaluated before or. So in order, we have not, then and then or. So if we kind of make an example, not is evaluated before and. So and A, or sorry, not at A and B, that's going to kind of equal not A and B. So we're going to negate A before we and with B. So let's do a little example with this. Not false and true. We're going to first negate our false. Not false is going to give us true. And what's true and true? True. True and true is true. So we end up with true in that expression. And then our and is evaluated before or. So A or B and C is kind of going to evaluate to A or B and C. So we want to make sure we do that and first, and then we can or the result of that with our A here. So let's do an example here. I have false or true and false. We're going to put our parentheses around our true and false. What is true and false? False. False or false? Also false. That one will end up equaling false. Let's practice. What is the final result of this Boolean expression? Find the answer and we'll go through it together. Give us a minute. Let me know when you have an answer.
False.
All right, I have a guess for false.
True.
I have a guess for true.
True.
I have,
Not true.
all right, I have multiple people saying true. All right, let's work it out and let's see. So let's add our parentheses. Boom. Our falses all get a parenthesis. Our ands get parentheses. And then that lone false all by itself. So sad. So let's operate these. Not false is going to give us true. Not true is going to give us false. What's true and true?
True.
And false and false. All right, so we've got true or false or false. Is at least one of these true? Yeah, and since we're using ors, only one of these needs to be true in order for our whole thing to be true. So our final result is true. So let's actually practice this. Let's make some actual code. So let's say we have a password class for seeing how strong someone's password is. So our password class, we've got a string storing what their password is. Our constructor is going to initialize that variable. And we have a method called password strength. If our password's length is greater than 8, we're going to print that password strength is good. Otherwise, we're going to say that password strength is bad. You need more characters. What if I want to increase my password strength check and only say that the password strength was good when there are more than 8 characters and it starts with a pound sign or a hashtag or an octothorpe? You pick your name. Those are all the same thing. So we can take that same method declaration and we can add an and, because we want to make sure that both these conditions are true for it to be a strong password. And we can use the starts with method, which is going to return true if our string starts with this thing. Otherwise, it will return false. So if our length is greater than 8 and our password starts with a pound, we will say the password is good strength. Otherwise, we will say that it is not strong enough. That makes sense? So what if I want to edit that so that the user gets a different message depending on which of the password rules they broke? What if it was not long enough or if it was not starting with a pound sign? What we're going to use is nested if statements. And this is what happens when you put an if statement inside the body for another if statement. So I've written it all out already. We've got our if our password length is greater than 8. Within the body for that if, we're going to check for our it starts with a pound. In our else, we're just going to say, hey, you need more characters. If they didn't pass that initial check, we're just going to say, hey, you need more characters. If they did have it greater than 8, we have a second if else. if the password starts with a pound, then the length is greater than 8, and it also is starting with a pound. So we can print that the password strength is good. Otherwise, we know that it's long enough, but it doesn't start with the right symbol. So we could say password strength is bad. You need to start with a pound. We can kind of, if we look at the flow chart of what this would look like, we have our first if up here. When that's true, we're going to then check our second if within the body for that one. So we have our if and else within our first if's body, our regular if first if's else, and then after that, all things are going to meet back in the middle. Our method is going to end. So no matter which path I take, I'm still going to get to that end box, but I can still only take one of those paths. So let's write a method called isHealthy. It's going to return true if the person's temperature is between 95.6 and 100.3, excluding both of those numbers. So that's to be greater than 95.6, less than 100.3. And it takes the person's temperature as a parameter. What do we need to do to build this method? What's our first step? So let's say we're just making a method. Say it again?
I don't know.
So we need to build the whole signature, right? So one signature. What's our second step going to be? The parameter is going to be part of the signature. We're going to use an if. What are we going to check?
If it's greater than 95.6 and less than 100.3.
All right, so if our temp is between the numbers, I'm not going to write them out because, yeah. So if it is, then return true. Otherwise, return false. Right? All right. Those are the same steps that I have. So, what is our method's signature going to look like? What's our access specifier? Public. What is our return type?
Boolean.
It's a Boolean, correct. We have our name is healthy. Keep running out of space. And do we have a parameter? Yes. We have our temp as a parameter. Perfect. I forgot to say the type of our temperature. That's the double, because, and you can tell it's a double because we have our double values there. So, how can we check if our temperature is between 95.6 and 100.3? Huh? We need an if statement. So, if, what are we going to check?
Is greater than 95.6. The two answers. Temp is less than 100.3.
Absolutely correct. Now, the reason we need to see temp here as well is Java is not smart enough to if I said temp greater than 95.6 and less than 100.3, pretend I wrote all of that and didn't run out of space. Java is not going to be able to associate that variable with this operator. It's just going to have only one operand for that operator. Java is going to be very confused. So we need to make sure we have a full Boolean expression on both sides of our logical operator. Otherwise, Java is going to throw a fit and not know what to do. So while we, as the programmer, can kind of extrapolate, I want to check temperature on both of those, Java is not going to understand. So we need to make sure we have that on both sides of our and here. So absolutely correct. We have our if temp is greater than 95.6 and our temp is less than 100.3. That should be ampersands. My bad. If that's true, we want to return true. Else we want to return false. So what we can actually do here is this is always going to evaluate to true or false, right? Do we really need an if statement? We can just return that condition, because if this is true, we return true. If this is false, we return false. So we don't need that if at all. We can just return the result of that Boolean expression, and that will work perfectly. Also, continue to pretend that those are ampersands and not the word and. I had Python on the brain. I'm sorry. All right, folks, that is our lesson. Any questions? I realize I did not stop to ask for questions at all. Any questions on any of that? All right, cool. And I will stop recording.